Hello everyone. Today, episode 2, we're gonna start writing our turn combat manager, which is gonna be handling all of the turn combat stuff. It's gonna be a pretty long part, I think. I realized last part I went over by like 10 minutes, but that was just because I was fumbling around. And that's gonna happen again this time, and I apologize in advance. But that's generally how these things tend to go. But let's go ahead and create a script. I'm gonna call it turn combat manager. Um, and what we can do, we are gonna need start and like update and stuff. Actually, we won't need update, but we will need start. I'm gonna get rid of them for now. What I want to do first off the bat is just create this private struct called combatant. And this will basically hold a bunch of information that we need from each combatant stats. So like, for example, it'll have a public combatant stats. I'll just call it stats. Let's go ahead and get as well the position of the object that this is attached to. We may also want I don't know, let's see, something like hold on. What else would be nice to have? I guess if you're doing like UI stuff, maybe that would be nice. So like a health bar. So like you could do like a need to be using Unity Engine UI. Although, if it were up to me, I'd want to move UI out of this. And like have that update based on the combatant stats itself. So yeah, I think I'll hold off on that for now. We'll figure out how to show health and mana at a later date. Actually, are we? Yeah, I think we'll do that later. We can always come back and add it in. It's not going to be too bad of a deal. But I'm going to go ahead and add a constructor for this, so it automatically does it for me, so I don't have to write all this stuff out. But it's just a constructor that takes in the stats of transform and generates things based off of that. And I think what we'll want, we don't need to, just to make it easier, I'm going to make another constructor. That only takes in that, just so I can do this dot stats equals stats. Okay, stats, and then this dot transform is equal to stats dot transform. Because this is a mono behavior, so it's sitting on an object, and that object undoubtedly has a transform of some kind. Okay, so we have combatants. So now what we need, we'll need a couple of things. And actually, what I'm going to do really quickly, what I meant to do last time that I forgot about, was to really kind of pretty this up. So we'll just do like stats here. Maybe give space. And we'll do moves. Maybe give some more space. And let's also give it a header for callbacks. I guess events would be more correct. Okay, but what all that does is it, when we go back to player, it just gives us a little bit more I guess that isn't, I guess we don't need that then, but it just gives us some space between all of this stuff, like, and gives us some nice titles. Anyways, the reason I brought that up is because we want that here as well. But first we need to figure out exactly what we need. Like we need like we'll eventually need some particles and stuff. We'll need like variables to control screen shake and all of that fun stuff. We'll also need like other things that just aren't coming to mind at the moment. But I guess first off, let's just create some more events that we'll need later. Unity engine.events. Let's create a header for, let's just do public Unity event on combat start. Public Unity event on combat end. Actually, yeah, no, I don't want these to be Unity events. Never mind. I want these to be yeah, let me add using system dot action, because we don't really want sorry, just using system. We don't really want this to be, we don't really care about it being visible in the inspector. What we want is just other scripts to know when the combat has started and when it has ended. So we'll just create an action. This without providing it with any types is just a void callback. Whereas this, we could give it some sort of type to know exactly which kind of result we received. I should really be making this clear about what I mean, but basically, whenever the combat ends, we want to know how it ended. So did the players die? Did the enemies die? Did we run away? So to that effect, we'll create another enum. This will have ran, won, lost, and then this will provide that information to whatever is subscribed to this event. Okay, we also need to have public bool in battle. Wow. Okay. And then I will get, actually I'll get to this in a second. So first off, let's create some private list of combatants, all list players, and similarly we need our enemies, and then we'll create two bools that are going to be players live, and then this just returns I should really be consistent. This should be in combat. Sorry, my brain goes all over the place when I'm writing stuff. But I'll try to be more consistent. But anyways, this just returns if for each combatant player and players. Am I doing this correctly? Oh wait, this should all be in get, right? Yeah. So this should be for each combatant player and players, if player dot is alive. Actually, this should be player dot stats dot is alive, and that's something we're gonna go write really quickly here. So in combatant stats, within these, we can just return, we can just make another really quick accessor is alive, and then this will just return if the current health is greater than 0. Okay, so now that we have that, this should no longer complain. And then if there is a player that's alive, just return true. And if it gets through all of this without finding a player that is alive, return false. And so we can just take this as well and do the same thing and make this enemies alive. And then this should be enemy in enemies. And then we can just have this return players alive and enemies. Cool. So that should work pretty much the way we expect it to. I suppose I could have made it a method, like instead of... it doesn't really matter. These could be methods, they could be accessors, it's all the same. Okay. Although I'm thinking I should make these methods, because I don't think these show up in the inspector. So let's actually go ahead and create an empty object. And this will be the turn combat manager, which will just have a turn combat manager script on it. Yeah, it doesn't show up in there. Cool. Let's go ahead and reset this as well, just so it's zeroed out. Okay. What else do we need? Let's see. So we do want, since we're doing this in 3D, I guess this would also make sense in 2D. The way I'm planning on setting this up, I should mention, is that the combat happens in a different scene. So we load into this scene to make it happen, and then we load back out when we're done, and then we save data or have persistent data, but through like a game manager or something in between, so we can transition back and forth correctly. We'll get to that towards the end. For now, I'll just make the combat scene. But what we do want is we want basically set positions for each of the players and the enemies, so that our camera work is a little bit more consistent. So we're gonna create a public list of transforms for the player positions, as well as a public list of transforms for the enemy positions. And then these will just allow us to snap the players that we receive, as well as the enemies that we receive, into their positions. Yeah. Okay. The next thing we need to do, actually, let's go ahead and set that up in here. We haven't done enough Unity work. So we have our one player here. So I'm thinking, let's go ahead and set the main camera to be aligned with this view. So if you just click on the main camera, go to game object and hit align with view, it changes our game view to be pretty similar to what we want. So let me go ahead and duplicate all of these. Say there's 4 party members in here, and you'd probably want to do this more carefully, but it's fine. So we have these as our player positions. Let's go ahead and duplicate these. And these will be our enemies. So now if we go on our turn combat manager, hit this little lock button up here so that the thing is locked, and then we take our first 4 players and drag them onto player positions. You can see it creates those, as well as for these, we can drag these into enemy positions, and that'll add those in there, and then we can unlock it, and we'll be fine. Cool. So now that we have those, let's go ahead and start actually coding in like combat stuff. I apologize for the noise. I'm adjusting my headset right now. Okay. Yeah, so we have all of this stuff. In fact, yeah, well, I'll just start it down here. Let's give ourselves some space to work with, and let's go ahead and create a public void start turn combat. And this will take in I guess an array of yeah, so this will be combatant stats array players and combatant stats array of enemies. Now, what we want to do is we want to basically create a combatant struct for each of the players and add that to our list of players. Um, so let's go ahead and first off, for each combatant stats player in players, let's go ahead first and set so yeah, yeah, this is something that you need to be consistent about, and in fact I'm probably gonna make like a global variable, but we want this list and the list that we receive to have basically the same number of players. Otherwise, this won't work. So for each, not for each, that's literally why I erased it. For int I equals 0, I is less than players dot count, or length array, I plus plus. If I is less than player positions dot count, then we can start doing the stuff that we need. So first off, we'll do players of I dot transform dot position equals player positions of I dot position. Then let's go ahead and create a struct. So combatant C is equal to a new combatant that is players of I, as well as players of I dot transform. Okay, and then let's go ahead and do players dot add. Did I call them? Yeah, players. Oh, this dot players dot add. This combatant we just created. Cool. And we have to do the same thing for enemies. So let's go ahead and duplicate this. And this will be for enemies.length and for enemy positions.count. And then enemies of I, enemy positions, enemies, enemies, and enemies. Okay. That'll add in all of our players and initialize the structs. And then we can go ahead and like eventually we'll want to set animator booleans and stuff as well. So like in here we'd want public animator anim, and then we just do like this dot anim is equal to transform dot get component animator. I can spell. I do the same thing in here. So eventually we'll be using that to like set booleans and stuff. Okay, and then finally, let's go ahead and start coroutine. Just like battle phase. Some Yu-Gi-Oh throwbacks in there. Okay, so we have that. Let's go ahead and create a private IEnumerator battle phase. And then basically while in combat, and like, yeah, while in combat should handle pretty much everything that we need. We can yield return. Actually, let me really quickly make the other coroutines that we'll need. We'll need the player phase, as well as the enemy phase. Actually, no. The way we're doing this, actually, okay, yeah, that's something we a design decision right here. So the way this is set up, or it's about to be set up, is that the players move first, and then the enemies, and then the players, and then the enemies. If you wanted to do what I was gonna do, but forgot to do, was have it be based off of attack speed. Then what you'd want to do is create some sort of list up here that has everyone in order of attack speed. That you just do that right here. You like make a loop, and then just order them based on attack speed. In fact, there's a way to do that with Link as well. You can order them based on a delegate that you give it. But for now, I think it's fine to just have it be players move first and then enemies. Although just to have it be set up in case we want to switch later, I'm going to create that list uh, order, I don't know, like move order, and then just do like, for now I'll just do we could have like change move order here, and then here I'll just do like move order dot add the same here. Okay, and then that way we don't need this clunky stuff. We can just have there. Actually, no, we do need those. Because the player phase is going to be slightly different. This is going to be the user or the player themselves giving commands to the system to use, whereas the enemies will be AI. And then the way we decipher that is probably just really easily is just have a boolean this player. I mean, you could check like if they're in the players list, but I feel like this is pretty easy as well to just have. Then we just have a public, not public, bool player, and then just do this dot is player is equal to player is player. Same thing here. Actually, let's just get rid of this. We're not using it. Okay. And then do a false or true and false. Okay. And then this will take in the combatant that we want to basically do stuff. Okay, so in here we just we'll just do for each for each combatant C in move order, if C dot is alive, or C dot stats dot is alive, then they can move. So we can do something like if C dot is player, then yield return new, or yield return start coroutine player phase with C, else yield return start coroutine with enemy phase. Okay, and then this so I should probably explain what coroutines are since I just use them so much. But what coroutines allow you to do is have methods that allow you to pause basically, and then come back to this point later. So what this is doing right here is while we're in combat, I should probably put a yield return null here. While we're in combat, it'll go through each of the combatants in the move order, and then it'll wait until they finish this coroutine, and so this coroutine will handle like moving however we want to, and then once this whole coroutine is finished executing, then it'll continue onwards to the next combatant in the move order, and so on until they're all done, and then it'll wait a frame, That's what null means. It just waits for a frame, whereas this one means wait until this coroutine is done. And then it'll go back up here, check the while condition. If we're still in combat, then it'll go through the whole process again. And I should probably check before each as well. If in combat, or if we're not in combat, then yield break. And so this will break us out of this loop, and then we can go and check our while condition again. But yeah, that should work pretty much the way we want. And the reason these are red right now is because we're not returning anything, so this doesn't know where to stop or where to get ready for a pause, basically. So if like just adding a yield return null here will fix that. And I'm gonna keep those here for now, but I think I've been recording for long enough to call that one part. So yeah, this is a pretty long episode as well, I think. But all we did was we started our turn combat manager. We have booleans to check whether or not we're in combat. And then we have events ready for when we start turn combat. We should also probably in here add if on combat start is not equal to null, then on combat start. And so that'll just invoke oh yeah, they have this cool thing now where you can just do that. So this just checks if it's null, and then if it isn't, then it invokes. It's super cool. Yeah. Yeah, we go through and we can order the. Yeah, I'll talk about ordering these in order of agility, at a later date. That's something we can add as a to-do here. Change move order based on attack speed. Yeah, okay. So now that we have that, and then in the next episode we'll probably start filling out the enemy phase first. And then we'll get to player input and stuff probably in the episode after that. But yeah. Anyways, that's probably gonna be all for this episode. Actually, really quickly, one more thing. So when we're done with combat, we can just do on combat. Actually, no, I'll deal with that later. Never mind. Sorry. That's gonna be all for this episode. Thank you all for watching.